This is an interesting question from the chapter Areas Related to Circle. We'll solve this question in two ways. We'll solve it from the first principles, and then I'll also walk you through a formula that you can quickly substitute and get to the answer. Start with the question. The area in centimeter square of a sector of a circle of radius 21 centimeters cut off by an arc of length 22 centimeters is what? What we need to find out is the area. What is given is the radius and the length of the arc made by this sector. Take a look at the image and then we'll know how we can go about it. We're starting with the first principles in method 1. Right? Center of the circle, talking about a sector. We need to find out the area of this sector, which is what the question is. What is given? Radius is equal to 21 centimeters. What else is given? The length of this arc is equal to 22 centimeters. 21 is the radius, 22 is the length of the arc. Ideally, what would you have wanted? You would have wanted the radius and the angle made by this sector at the center of the circle. If that information were available, the area would have been equal to theta divided by 360 into area of the circle, which is pi r square. R available 21, pi 22 by 7. If theta were known, we would have been able to quickly arrive at the answer. No, we don't have theta. So we're going to use information about length of this arc to compute theta as step number 1. So in method 1, step 1, the missing information is theta. Let's find out what that theta is. Length of the arc is equal to theta divided by 360 into circumference of the circle, which is 2 pi r. Is length of the arc known? Yes, 22. Theta is what we are trying to find out. Pi is 22 by 7, r is 21. So we have all information other than theta. So we can plug in all of that, find the value of theta. That's step 1 of the first method. Length is equal to 22. Theta divided by 360 times 2 times 22 by 7 for pi, and the value of radius is equal to 21. Divide both sides by 22. 22 gets cancelled with 22 to leave us with a 1. Cancel the 7 and 21 to leave us with a 3. 2 times 3 is a 6, cancels with 360 to leave us with a 60. So 1 is equal to theta by 60. 1 is equal to theta by 60, or theta is equal to 60 degrees. So step 1, we wanted to find out the value of theta, which is equal to 60 degrees. Now step 2, let's find out the area of the sector. Step 2 is finding out the area of the sector. Formula is equal to theta divided by 360 times pi r square. 60 is theta that we have computed, divided by 360 times 22 by 7 times 21 times 21, right? R square is 21 square, 21 times 21. Cancels to leave us with a 6. 7 and 21 will cancel to leave us with a 3. This together is a 66. 6 cancels with 66 to leave us with 11. So area of the sector is 11 times 21, which is equal to 231 centimeter square. This is method 1. Method 2 is using a formula directly. Area of a sector is equal to half LR. What is L? L is the length of the arc. R is the radius of the circle. We'll compute this answer and then we'll see why this formula is the same as what we got earlier. So this is half into length of the arc is 22. Radius is equal to 21. 11 times 21 is equal to 231 centimeter square. If you remember this question is going to take you 15 seconds. That's all. Now, how did this formula come about? Area of the sector is equal to theta divided by 360 times pi r square. Let's see whether this translates to the same thing. Half into what is length of the arc? Length of the arc is theta divided by 360 times 2 pi r, right? This is length of the arc. Half length of the arc times radius is what we have. This half gets cancelled with this 2. Pi r into r is a pi r square. Theta divided by 360 times pi r square is what we have, which is what the formula for area of the sector is. So an alternative way to arrive at the answer is area of the sector is half into length of the arc times radius. If you know that formula, just 15 seconds to arrive at the answer. 231 centimeter square is choice C.